that yesterday CAMP organized its very first offline teaching program at the CSIR NISPER in association with the CBSC. For this program, more than 50 teachers from Delhi participated and attended sessions by Professor Shamista Banerjee, Department of Biochemistry, School of Life Sciences, University of Hyderabad, Dr. Hassan Javed Khan, Chief Scientist at the CSIR NISPER and Editor of Science Communication, Ms. Shubha Kapil, Assistant Editor of Vigyan Pragati and Effective Science Communication and Writing. During the session, Ms. Arika Mathur, Head Operation and Assessment, also gave an orientation to the teachers on the objective of CAMP and how it aims to unearth the innate talent and skill in our students and the importance of teachers in this very endeavor. If you are a teacher and would like to register for one such training program at your nearest CSIR lab, please check out our upcoming CPD training program list on our website and feel free to enroll for them. For any support, you can get in touch with our team through the given helpline number in the chat below. Am I audible to everyone? I'm getting comments that my voice is not clear. Can you please give a thumbs up if my voice is clear and loud to everyone? Okay, everyone, perfect. So in case if you're not getting, my voice is not clear for you, please check your system again because I'm receiving, other students are receiving proper audio communication from me. Perfect. So coming forward, I have a big announcement for all the young space enthusiasts. I would like to announce that from 9th October to 13th October, CAMP is organizing its scientific excursions on the occasion of World Space Week at the Indian Space Research Organization's National Remote Sensing Center, ISRO's NRSC, Hyderabad. If you would like to participate in the excursion and get a chance to explore, discover, and engage with various scientific disciplines in a real-world setting at various eminent CSIR laboratories or research disciplines in a real-world setting, so check out the link below to learn more about how you can participate. For any support, you can even get in touch with our team through the given helpline number in the chat below. Well, coming back to today's session, we have with us Dr. Suman Tewary. He is a senior scientist working at the Advanced Material and Processes Division at the CSIR NML, Jamshedpur. His core expertise lie within machine learning, image processing, signal processing, instrumentation, algorithm development, and Android application development. Now, without any delay, I would like to invite Dr. Suman Tewary to enlighten our students with this exclusive workshop on Introduction to Artificial Intelligence and Machine Learning. So you're on mute.
Yeah. Thank you, Aniket. Good afternoon, students. So I'm going to talk more about artificial intelligence and machine learning. Okay. Before we start, do you have any idea, like what is artificial intelligence? If you know, give thumbs up. Yeah, I think Hardik Kohli is telling yes, he is doing. So basically, intelligence is what nature has given us the moment we took birth, right? At every step of our life, we are having some or other form of intelligence. Like we started learning ABC, we started learning how like talking, we started learning of different characters like our objects. Okay, so how we are perceiving those things, like A for apple, B for ball. Okay, because we have been trained in such a way, our parents have shown this letter corresponds to A, this object is apple. Okay, and after multiple iterations, we understand, okay, this character is A and this object is apple, or this object is a ball. So like that, if we want a machine to learn all these things, which is basically an artificial intelligence. So how we can do? We can have different kind of coding, different platforms are available for it, and the people across the world are using these tools to develop multiple applications where this artificial intelligence is required. And it's simple. It's in simple words. It is basically trying to automate things where, as an individual human, is much superior. Okay. So, if we see the definition of artificial intelligence, Richard Knight at 1991 defined artificial intelligence as a study of how to make a computers do the task at which at the moment people are better. And artificial intelligence is basically the simulation of human intelligence processed by machines, especially computer systems. Specific applications of AI include expert system, natural language processing, speech recognition, and machine vision. And we'll be talking about more of these things specifically with some examples, how people can do different, make different applications, how multiple things which are available in the internet, how those things works. Okay. So if you compare brain versus computer, so what we want the computer to learn something which as an individual we are doing. But if you compare our brain and a computer, so brain is made up of basically nerve cells, which is also called neurons. Whereas if you compare a computer, it is made of silicon transistors. Okay. So I think students in class 9, 10, or 11, 12, they know what is transistors. Okay. So in our human brain, we are having around 200 billion neurons, and there are multiple connections within those neurons. And whereas in computer, you know about the RAM, hard disk, all these things, you know, SSD and all those things. Okay. And in neuron, the size of a neuron in human brain is in micron, whereas if you talk about the computer, the transistor size is in nanometer. Okay. So if you might have heard of, like, Samsung is making very small chip, okay, for iPhone, new iPhone, and all these things. So what will happen if the size of transistor is decreasing and it is coming in the range of 2 or 5 nanometer? So basically, what is happening? A big computational task can be done on a smaller platform. Like, if, for example, if you remember, we used to have, I think you have seen some photographs of those. We used to have big computers in our home. Okay. Now, the same computation part can be done in a much faster way on this small smartphone. Okay. So the form factor is decreasing a lot. Okay. How it is decreasing? Because the transistor size is decreasing. Okay. So in a very small area, a very high number of transistors are there and they can perform all these tasks. Now, if you talk about the energy consumption, so if we do any task by us in our human brain, so the energy consumption is around 6 to 10 joule per operation per second, whereas in computers it is 10 to 15 joules per operation per second. And we, as an individual, we have the learning capability, whereas computer is having programming capability, and that programming can be done by different languages like C, C++, Python, Java, and all those things, right? So, we hope that the brain is a form of computer, and our goal is we can create a computer intelligence through programming, just as people become intelligent by learning. But we see that the computer is not like human brain, and the computer performs tasks without understanding and what it's doing. And many times, this thing is very important. Does the brain understand what it's doing when it solves a problem? Like, if you have a mathematical problem of adding two numbers or subtracting two numbers, do you really know what your brain is doing at that point? Because what is happening, it is something like with practice kind of thing. So with practice, with many times of iterations and all, very simple calculation, all these things we're doing by ourselves. We don't even understand that our brain is calculating all those things in behind the picture. Okay, whatever we're doing, we can think that we are solving a problem, but actually the brain is doing all those things from the intelligence we have developed by learning those problems. Okay. So nowadays, if we see, since we are from CSIR, CSIR is focused on scientific as well as industrial research. So nowadays, industry is going towards industry 5.0. So what is 5.2? So in this fifth revolution, so what it is talking about, that it is emerging in the phase of industrialization that is human working alongside advanced technology, where AI-powered robots is enhancing the populace. And the key factor on here is human centricity, which means that human perspective is involved at every step of our problem. Resilience, that means the capacity to withstand or to recover quickly from difficulties. And sustainability, that means the ability to be maintained at a certain rate or level. So these are the technological pillars of Industrial 5.0. So within those pillars, cloud and edge computing, artificial intelligence, mobile technologies, 5G, and 6G. I hope you have heard about 5G communications, right? Like earlier we used to have 3G, 4G, now we are having 5G cellular communications. Then industrial IoT, robotics, 3D printing, additive manufacturing, even machine interface, and big data analytics. So before we proceed about the artificial intelligence and machine learning, we should know what is data. So basically, data is essential for all kind of programming and all, which is being done on the computer. But data means that this can be a fact or statistics collected together with a reference time. If you see here, data means information, graphs, some measurement values, some facts, some quantities, image or signal. We'll be focusing most of these examples in the form of image or video. So that is why I wanted to focus here. What is image? If you see, image is basically a 2D matrix containing the intensity values. And if you see the digital image having n rows and n columns, the representation is in such a way fxy, and xy is their coordinate point. If you know the coordinate geometry, you know that you can get any point in 2D space, 2D plane by this xy coordinate locations. Okay. Similarly, in any image, we can have the pixel locations using this coordinate locations and density values. Right? And by applying different algorithms, we can have these images as per our requirement, like whatever operations we want to do. So some of the imaging uses using the surveillance and geological mapping, science and medicine, diagnostic and functional evaluation, non-destructive evaluation, industry automation, and material characterization. So those things are essential, where instruments have given a critical role for acquiring those images through different instruments. Chat, I think someone is asking if in this calculation. I will try to answer these comments afterwards. Okay. So I hope it is fine. So you can write your comments on your chat box, and we will try to address all these things. Right? So this is the relationship between artificial intelligence, machine learning, deep learning, and data science. You see, the big gamut is the artificial intelligence, where we want the programs with the ability to learn and reason like human. Within that, there is a subset which is basically machine learning, some form of machine learning algorithms with the ability to learn without being specifically programmed. We'll talk about it in details. And within this machine learning, we're having a specific subject which is called deep learning, which are where artificial neural network is there, that can adapt and learn from vast amount of data. And if you combine this AI with data science, so where there is a flavor of statistics and maths, programming and domain knowledge, so the data science becomes a field of study combining statistics and math, programming and domain knowledge to extract meaningful insight from the data. Okay. So why it is essential? Because for any kind of problem statement, we should have the domain knowledge. What is the problem? How the problem is occurring? We should have some knowledge of statistics and mathematics, some knowledge of programming, be it C++ or Python or any other platform, and the whole overall knowledge about the artificial intelligence to come up with the solution. So there in AI, there are multiple subfields and techniques. I will not go into detail about it, but there are specific things like machine learning. Within that, we have supervised learning, unsupervised learning, reinforcement learning, semi-supervised learning, task learning, ensemble learning. Within deep learning, we're having artificial network, convolutional network, like that. We are also having natural language processing, computer vision, robotics, expert systems, knowledge representation, reasoning, speech recognition, virtual agent, and chatbot, like ChatGPT, autonomous vehicles, self-driving cars, the recommender systems, game playing with AI, knowledge graphs, cognitive computing, emotional AI, and swarm intelligence. So all of these things are using some or other form of programming or from the artificial intelligence domain. Someone has asked that ML and DL are subparts. Yes, basically I told you that the superset is artificial intelligence. Within that, the subset is machine learning, and deep learning is a specific focused form of machine learning, where only artificial neural network and all these things are being used. So in this example, I'll be showing a basic image processing pipeline for AI application development. So there are some basic steps which are required for extracting the meaningful information from an image. I also show you in the form of an image, but before going there, different steps are like this. So image, as we discussed, that is a matrix of numbers, and we can have a single channel gray image, or we can have a multi-channel color image. Okay, what do you mean by multi-channel? You know, any color is a combination of red, green, and blue. So when we extract the color, different channels from a color image, we get a red channel, green channel, blue channel separately. Any kind of processing. And processing pipeline includes pre-processing steps where noise removal, enhancement, setting correction, normalization, all these things are done. Then there is segmentation where auto threshold thing is being done. Then there is some post-processing where morphological operations, edge detection is being done. Then feature extraction using this edge regions or pixel values or masking is being done. Finally, detection result are shown within the detection box, bounding box, region labeling, counting, and classification is done. I'll show you the example. So if you see, this is an example of so this is an example of a color image. So this color image is a microscopic image of blood cell. So you know malaria. I hope all of you know what is malaria. So what is happening in case of any malaria infection? The malaria parasite infect the RBC or red blood cells. So if you see this image in your top left, there are all RBCs, but within those RBCs, there are some RBC where the texture is a little bit different compared to others. Okay. So the task here is to find out all the RBCs, then the human can or the expert can tell which RBC is infected and which is not infected. So the first step is segmentation. We will segment the image so where all the cell part can be seen. But here some noise is there. We want to remove this noise or background clutters. So for that, we're using some post-processing, erosion, and hole filling, where you can see the clean binary image is being shown here. Finally, from this binary image, we can draw the bounding box across the cells. So after this bounding box is drawn, a user can tell for all these detected cells, which one is infected and which are not infected. Okay, so the steps are something like this: acquired image, color image having RGB channels acquired from light microscope camera, segmentation step, what's threshold on green channel, and post-processing using morphological processing, erosion to remove unwanted clutter, whole film to get all pixel area, the region of interest. Finally, we're labeling it with blob detection with bounding box for further analysis, that is counting, texture, color, and other things. Yes, Shaurya, all these are basic image processing pipeline. So these things are essential for development of any artificial intelligence. Why it is essential? So after getting all this labeling, all the bounding box, as a human expert, we can tell which one is infected and which is not infected. But a machine cannot tell. So we want the machine to learn from this detected cells and to extract the feature, texture feature and all. So then the machine will automatically learn by the algorithms which we'll be discussing. So using this algorithm, it will try to find out the feature and try to find out optimal fit. So that will tell the program, okay, this cell is infected one and this cell is not infected. Okay. So that is why this image processing pipeline is essential for artificial intelligence development. So machine learning as a whole is programming computers to optimize the performance criteria using example data or past experience. So there are different forms of machine learning as we discussed earlier. Supervised learning, within that regression and classification is there. Unsupervised learning. Basically, supervised learning means we're having the level data and we give the level data to the computer to make the algorithm. On the other hand, with unsupervised learning, we are not leveling data, we're just giving the data to the computer and it can assess the data by clustering, association, link prediction, or data reduction. And finally, we have reinforcement learning like machine playing chess. So as a process, we need to first define the objective. That means we define the measurable or quantifiable goals and use this stage to learn about the program. Then we have the step of data processing, pre-processing. So in data preparation, we have normalization, transformation, machine value, outliers, and all those things. And after that, we start model building. Within that, we have data splitting, feature engineering, estimating performance, evaluation of model selection, and all. And after that, we evaluate the model by means of accuracy, and we can tell which model performs better than the other one. And finally, whether the results make any sense of them. And finally, after the evaluation is done, we deploy the model for the applications. So we'll start with the example of KNN. So basically, KNN is a supervised learning. And what do you mean by that? That we are given a level data set of observation XY, and we like to capture relationship between X and Y. So the goal of this KNN algorithm is to find from the unseen observation X, so that HX can confidently predict the corresponding value Y. So the k-next level, basically this is something like distance calculation. So in coordinate geometry, we find the distance between 2 points like x1, y1 to x2, y2 is root under x2 minus x1 square plus y2 minus y1 square. Similar to that, if we are having this many number of points like xi1 to xip, and we are for n number of samples, the Euclidean distance is calculated in such a way like the square root of xi1 minus xl1 square is xi2 minus xl2 square, like that. So I'll show you this thing with some example. So before that, we should tell like how this thing works. So the steps are: choose the number of k neighbors. We can say 2, 3, 4, whatever number of class we want. Then take k nearest neighbors for a new data points according to your distance matrix. You can define randomly also any random data points, and from that we try to find out the Euclidean distance of all other points. Okay, like if it's x1, if it's a class problem, I'm showing in detail x1, x2, x3. So it will try to find out all distance from that x1 to all other points, and then assign a new data point to the category where you counted the most closest neighbor. So we will give this example of iris data set. See, iris data set consists of 150 number of samples where there are 4 features: sepal length, sepal width, petal length, petal width. If you see on the top right, there are 3 classes of flowers, and bottom left, the feature set. So all number of observations are there where sepal length, sepal width, petal length, petal width are given, and target, that means the class or species, is given. If you draw those features in your 2D space, this looks something like this with the blue RGB colors. Okay, so that blue corresponds to Setosa, green corresponds to versicolor, and red color corresponds to Virginica. If you see, Setosa is distinctly different compared to versicolor and Virginica. Okay, so we can easily distinguish this part. But if you want to distinguish between versicolor and Virginica, we need to use the distance calculation. So if you start with 3 nearest neighbor, so 3 random number will be given, and any 3 data points will be assigned to that class, and it will try to find out optimal distance between all the points, and whichever is the closest to that specific point, it will given a level to that class. So if you go to this link, medium.com, you'll find out this code data code. You can also find it in kaggle.com also. So in Python, I think you'll be learning that in class 11 or 12. So we need to first load the iris data set from this input data set. And after loading, you need to assign the data and target values, X and Y. So X is your data and Y is your target. That means 3 classes. Then we need to split the data set into train and test. So why we split? Because we want non-overlapping data set to avoid any kind of bias in our data set. So after splitting, we'll try to build a model. The classifier equal to k nearest neighbor classifier and number of neighbors equal to 3. And then we train the model with this classifier.fit, extend and y train. And finally, we can predict using this accuracy score, prediction equal to classifier.predict, and accuracy can be calculated as accuracy score within from y test to y trade, and that can be printed and will be your 26% accuracy. So students, these examples are already available in internet. If you simply write Python code for KNN classification or ANN classification, you can get it. Now we'll talk about the ANN. So that is basically artificial neural network, and this is the basically backbone of all artificial intelligence and deep learning, which we'll discuss. So as we discussed earlier, or the name suggests itself, artificial neural network is nothing but similar to our human brain. Okay, so if you see the diagram, the human brain cell. Okay, so there are different parts in the cell, right? So there are dendrites and cell body, then axon and then terminal axon, and 2 neurons connect to each other using synapse. So if you compare these two, the soma, the cell body approximated as a neuron in ANN, dendrites, the input to the cell, approximated as the input. Synapses, it is a weight associated to the input or associated to the weight or slope, and axon is the output to a neuron approximated by the final output. So if you see in the first figure, so x1, x2, and up to xn, all are having some kind of weight, w1, w2 to wn. If you summarize, sum all these things and add it together, so x1 into w1, x2 into w2, like that, and we add, we get some output y. Okay. Now, assume a complex situation where all are interconnected. So these weights are also there, and there are multiple hidden layers. So input layer is having input feature, then hidden layers are interconnected to each other with some weight. Okay, and finally the output layer is there. So the output layer will be having a complex equation of all input layer with some weight and hidden layer values, so that a very complex equation can be there, and that will optimize your problem. So initially in the first step, we randomize the weights, and the target is that the output should be as close as the target value. So how it can be close? So we just find out the difference between the actual output and whatever you are getting as in the first step itself. And the computer will try to minimize this error by multiple iterations. Okay. So this, in a nutshell, if computational model of ANN is basically inspired by human brain, that algorithm try to mimic the brain, and it is massively parallel distributed system and made up of simple processing units or neurons, and knowledge acquired by the network from a learning process. So it is an iterative process, and every steps the algorithm try to minimize the error, and this is a resistance to error in the training data, and only issue is that it takes long training time and it's having fast evaluation, and the architecture is input layer, hidden layer, and output layers. The moment you talk about very dense network, it comes under deep learning. There are some comments. So iris data set, as I told you, I'll give example again. So artificial data in means artificial network. Yes, such to our human class. So yes. See, ANN gives enough to compute. It is not like that. ANN is an algorithm. Within that algorithm, the input feature is giving that's summed output to the next level. Okay, so that is how it is corrected. So, if you see, when you talk about ANN for this highest data set, so you see there are four features: simple length, simple width, petal length, and petal width. And there are three kinds of flower: setosa, versicolor, and virginic. So each flower will having these four features. So for this setosa flower, there will be some sepal length, some sepal in centimeter and sepal width, similarly petal length and petal width. Okay, so that will be different for versicolor and virginic. Because of these features, it is distinguished between these three classes. And using this algorithm, we're trying to classify the data for these three classes of flower. KNN. So KNN basically is your K nearest neighbor, and KNN is artificial neural network. So here the algorithm is a little bit complex. We have to first define the base model also. So this base model, as it's shown in the figure, so it is having a sequential model kind of thing where there are 6 number of hidden layers. Input dimension is 4 features, and activation method is same. And in the final output, you are having a dense layer of 3 neurons, and the activation function is softmax. So similar to that previous example, here also we need to import multiple libraries, keras, okay, or sklearn. Then we need to load the data set, and then we level the data set into x and y, x is training and y is levels. And then we have this encoder, level encoder, and encoder fit, and encoder y. This basically encodes the class values to some integers. So there are some values given for setosa, versicolor, and virginica. So that will be converted into some integer values, and then convert integer into dumb variables on it. What it means, that it will create a matrix where class 1 corresponds to the first column, class 2 corresponds to second column, class 3 corresponds to third column. So it is basically categorical. And then we have the estimator where the classifier is there, and we have to for the and the result can transfer validation score, and then finally we can print the accuracy. So all these things are available in your machine learning mystery.com, and you can get the example from there. So I will show some example using imaging and applications. So this is basically the electromagnetic spectrum. So within that, we have a visible spectrum. So students, we know, I think it is you have learned in class 9 or so. So in visible spectrum, the wavelength varies from 380 nanometer to 750 nanometer. Okay. So that's VQ. If you see, VGYUOR. Below this is ultraviolet, and above this it's infrared. Okay. So normal range is 400 to 700 nanometer, and for any primary color, red and blue are the primary colors which mix to create any number of colors. And it is being used in photography, all kind of cameras, imaging, smartphone or DSLR anywhere. And microscopy, where biological sample or metallography has been done. Fluoroscopy is used, endoscopy for internal organ assessment or in medical applications. So I think most of you have uploaded some image in Facebook. Okay. The moment we upload an image, Facebook can detect the face and tell you that this face corresponds to some person X, this face corresponds to some person Y. How it is true. So there is a face detection algorithm which is known as Jones algorithm that is being used here, and it is used in most surveillance cameras, Facebook search engine everywhere. But Facebook has gone one step ahead by not only detecting the face but recognizing the face. So from multiple data sets, you can actually recognize the person. Okay. So if you have uploaded many images and you have tagged yourself or your friends in those data, Facebook has backup, and in the backend from those data, it's training its algorithm to detect whenever you next time you upload any image. The moment you upload the image, it will first detect the face and it will automatically tag. Many times, obviously, it's asked for suggestions, but you see, whenever you try to tag it, it will give you the most accurate suggestion. And the second form of application is optical character recognition. Basically, it is, if you see this image in the bottom left, this Apple support and this and a number that can be detected by the computer. Not spell it out. Apple support and 1-800-275-273. So what is being done here? It's accurate digital image scanner head or smartphone camera, and it can detect text or classify the characters to without text. In CSI, CSI, they have developed this form of device which is called the penner. Blind person can read using braille, but nowadays braille printing is not being done in the regular way. So they're deprived of new information. So what this device can do, it can help blind or visually impaired person to read any digitally printed text. So the person can scan the paper and in any orientation, because blind person doesn't know what orientation he or she is scanning. So in any orientation, if the person is scanning, it will read out the text, and by listening to the text, the blind person can get more and more information. Similar kind of application is also developed in smartphone. That is also called the Penner, and it's available in Google Play Store. So it can also help in a similar fashion. So it basically from the image camera or from saved images or video, it can read out text. We'll try to answer after 10 minutes, okay? I think 10 minutes will cover most of the things. Okay. Now, this is a very useful example of machine learning. So, what is it is? It is basically ANPR, automatic number plate recognition. So, online challan is there, right? So, if someone is over speeding or not following the traffic rules, the online challan is being sent to his home or on his phone by SMS. How it is being done? So it is being done by in this way. So the first step is the number plate detection. So the camera detects the number plate and the segmentation all the numbers and the character values using machine learning. So it using different algorithms are there, like LSTM and all. So it's basically tell you that specific characters or LP 5356 so if the camera detects that person is not wearing a helmet or overspeeding or standing over the zebra line, so it will detect the number plate and it will send a challan to the person. This is an example of ANPR. So this simple example shows you like if in your home anyone is entering a car or bike, the person can be that number plate can be detected and that can be stored in the server. And simple example is shown using the challan system, which is being done in many countries nowadays in India also, in Delhi, in Patna, in many metro cities it is available. For example, this is devices for visually impaired persons. There is a color blindness among some people. So color detection can also be done. Another very good example is Tesla autopilot. I think most of you know about this self-driving car. So Tesla has developed a self-driving car, and there is a lot of sensor fusion, machine learning involved in this kind of development. So this video shows you how the device works by itself for automatic navigation in the night time. So the person is telling where to go, and automatically the map is generated for that. So there are many sensors in this Tesla. So there are many sensors there in Tesla. So all sensors are fused together to give this kind of information. So the car, if you see, the person is not even touching the wheel of the car. So it's basically navigating by itself. It is moving left or right, and it is sensing pedestrians, cars sideways. It can detect the traffic light, where to stop, where to go. So all these things it can do. There are some examples for diagnostics. So this is basically a cancer image showing that like in blood cell, tissue cell image. So if you see, so there is multiple stained cells of brown and blue color. So what happens like the expert need to find out how many numbers of brown cells and blue cells are there in one field of view. So using different approaches, we have developed this thing like step selection, segmentation, color normalization, segmentation of cell area. After that, classification using RGB color features with different kind of classifiers such as ANN, KNN, night bias, symmetry, and random forest. And then we have shown the pseudo colors. So if you see, the input image is here, and the output image is having pseudo colors of red, orange, yellow, and this auto ISS query is automatically giving the scores correlated with the expert methodology. This is a thermal score for retinal screening. So, atlas was essential for diabetic because of diabetes, because they lose their eyesight. So, there are some damages in the retina which need to be at an early stage. So, that can be done by children. So using this handheld ophthalmoscope, the patient's retinal image is being captured, and different kind of features like exudates, abnormal blood vessels, and then retinal blood vessels, retinal macula, all these things are detected. As you're from animal, we will discuss some of the applications for metals also. So, like this is an example of a metal where same image and microscopic image has been done. And for the texture of these images, there are different kind of materials which are to be calculated, like for a phase extraction, that material is CITP. So what it is being done is in the first step, it is detecting all those regions, and from the texture itself, it tries to classify these classes, and then it label it with pseudo colors and show you this bar graph, okay, for the phase extractions. Another example is microstructure classification of deep learning. So similar to the previous example, here also the background developed by the experts can be compared with the predicted image output. And the different some companies like Olympus has added true AI different technology to detect their multi-phase analysis in composite materials. As an example of edge copper. Edge copper, if you use simple image processing approach, will try to will get more about more area which is not correct, but by using deep learning approach, you can actually accurately quantify the area. Nutshell, the future of digital technology industry with AI is as shown below. The instruments with edge IoT features, sensors and instruments having physical measurements, edge devices will be available, image sensors for alert, sensor-based services are sensor data for different measurement using image and signals, and there are multiple sensor observation or fusion of data. Then there is analytics, where training data set and AI and algorithm development is involved. And there are some fault prediction and monitoring is there, where instrument interpretation and data analysis is important and characterization of process parameters. Finally, the productivity can be increased by combining all these things. I think we can take some questions. Aniket? I think during the presentation also I've tried to answer most of the comment in the chat box, but still if something is missing, you can. Like ML and DL are some parts of AI adapting I've already mentioned. Image processing pipeline. So what is also threshold? So basically, it is a threshold algorithm. Like from the intensity value, you can classify the image into two levels, white and or binary image. That is using also threshold. KNN is never. KNN is artificial neural network, which I already mentioned. The program, how the ML techniques. Yes, like I've shown two examples, KNN and ANN. There are many other examples which are available, and using Python or C++ or Java, you can do that. So even in the curriculum, I think Python is there in 11, 12. So you can use it or any other platform. So platform is not an issue. If you just Google it, Iris data classification, and whatever platform you are using, C++, Java, Python, anywhere, that examples are there. You can use them. Thank you for this thing. Too good for visual input. Yeah, because as I mentioned, that Braille thing is not being published nowadays. So it is very much essential to have some device where this visually impaired person can use those for to enrich their information. Okay. Yeah, blind person is not sending signal to brain. Basically, it's happening like that the sensor is acquiring the data. From the data, it is basically giving audio output, like in my headphone. The device is connected in the specs, okay, and that automatically tell the user or read out a text or tell the color of an object and all those things. So will this come an example? No, it will not come an example of class 5. So, not much. Yeah. Anything else? If anyone want to ask.
So if you have any other question, can you please raise your hand? We can. You can raise your hand. Related to AI.
I did not understand the microscope. I think you will have that lab session in your school, I think class 9 or so, where you will be shown what is microscope. Okay, and the basic example will be given with some onion skin and all those things. Okay. Or simply, you know that for any kind of blood test, if you go to a pathology center, you give your blood, so that expert takes the blood, take a drop of blood in a slide, and make the slide and observe that with this microscope. Any other questions? If you don't raise, you can also write in the chat box also.
I think as we're close towards the end of time, if they have any queries, they can mail to us or directly they can connect with you. That can be more convenient, I think, because the queries we have a curious.
Yeah, that's fine. So
Yeah.
what we can do, like if you can summarize all the queries and then send me a mail if there is
Exactly,
any.
that would be arranged, right?
Yeah.
So we can just
So that
share
will
the
be the
email.
best thing.
Yes, I'll just type in my email address and they can just
Yeah,
send
just
the queries to me. So for the students, if you have any query, please write to me at my email address, aniket@camp.res.in, and I'll share your queries with Dr. Suman and we'll get back to you at the earliest.
so what will be there, like all the queries will be clubbed together, even if let's say one person is not asking that thing, but still he or she will get the idea from that question. Okay, so that's why I told you to collect all the questions and then we'll try to answer them.
Yes, and we share it with all the audience because just in case, so that all the answers get shared with everyone.
Yeah, yes.
It would be because we have a curious mind with us, all curious minds.
Yeah.
So thank you so much, Dr. Suman, for this wonderful session. And I must really tell you that sessions on robotic, machine learning, coding, and artificial intelligence, these have always been very motivating for our students. And the way your insights and expertise in the field of artificial intelligence, they were just not only informative, but also incredibly inspiring. And personally, I've had the benefit of attending your lecture in person live at the CSI NML. And I just wanted to our other students also to have that opportunity to hear you. And since that cannot be arranged for everyone, so we have this live session with you so that everyone gets benefit from your expertise and knowledge that you're sharing with us. Thank you so much, Doctor.
Thank you, students. Okay. See you soon.
Definitely. We look forward to many more future opportunities to collaborate with you.
Sure. I'll be available.
That will be good. Thank you so much. So now I have a message for the student that
Thank you. I'm leaving then. Huh? You can continue.
Thank you so much. Thank you, Doctor.
Thank you.
Thank you. Last but not the least, I would like to remind you that registration for NASTA 2023 and the scientific excursions are open. To know more about the ISRO's NRSC scientific excursion, check out the link below for the scientific excursion and don't miss out on the opportunity to visit various prestigious labs and organizations like CSIR, ISRO, DRDO, and many others. In case you want to participate in these excursions, you can connect with your nodal officer, camp nodal officer, or the concerned teachers or you can also check our website or connect with us through our support helpline numbers. So if you have any other query or would like, seek additional support, feel free to reach out at any of our social media handles or helpline numbers. We are here to assist you on your path to success. Thank you for your active participation and dedication to your personal and professional growth. Also, we would love to hear your feedback so we can keep improving our content. And I'd like to mention that these answers they will be kept confidential, they will be kept anonymous and won't be shared with anyone. So we would love to, we would appreciate if you could share a small testimonial video describing how this knowledge sharing session by CAMP helped you. You can either upload your video on your social media handle and tag us, or you can share the video with us and we'll post it directly on our social media handles. Thank you so much. And if you have any query, please write to me at aniket@camp.res.in or share it with us on the query on the social media. Connect with us through messages, or you can call in at the helpline numbers that we have mentioned in the chat below. Thank you so much, everyone. Thank you so much. Now we will end the session and we will all meet soon for another exciting workshop by Camp. Thank you so much.